Hello everyone, I am Jyothsna, working as assistant professor at VNR JYOTHI Institute of Technology. Today I am going to give the session on image processing and computer vision. In this, I am going to cover the topic is digital image fundamentals. Okay, so before going to the topic, what is an image? Okay, why should we focus on the digital image? What is the importance of this? In nowadays, everywhere are images. Okay, if you see, have you ever wondered how your face is unlocked with the your smartphone? And even you can observe the Google Photos, where how it detects your names and how it is grouping all these photos. Even if you see the self-driving cars, there how it is autonomously working itself. Okay, these everything, the magic behind all these image processing and the computer vision. So in modern technology, there is a need to learn this image processing and the computer vision. So we'll see what is the image processing and the computer vision and how it is interrelated, and what are the techniques we are using in the upcoming sessions. And today I'll cover only the fundamentals of image. Okay, and now let's begin our journey. So we'll see what is the image processing and the computer vision. So image processing, so means what? Here we are processing the image. What is the raw image which is processed? Mean finally we are enhancing the output of enhancing the image. Okay, so what is the use of this? Means you can improve the image quality here. Okay, so that will be useful in further process. So there, that is the main objective of the image processing, as you can see on the screen. So you can see here the image processing is the input is image and the output is also image. Okay, so what is the output you will get here? So this is the image processing definition. Here the input is the raw image and we are using some algorithms. After applying algorithms on the image, so that you will get the enhanced version of the input image. So that is the main objective of the image processing. But when it comes to the computer vision, so the computer vision, the main object of the computer vision is it will make the sense to the machine. Means how human will sense by seeing any object, same thing will apply onto the machine. So we are making the machine to understand the scenario, and it will interpret the data. Okay, that is nothing but the computer vision. Okay, so here we are interpreting the data from the image. Okay, so after interpreting the data, you can use it further. Either you can take the decision based on the that interpretation values, or you can use an making sense to the, we are providing intelligence to the system with the help of the images. So that is the main objective of the computer vision. Okay, next you can see here the definition. So what is the here we are manipulating and enhancing the images in the image processing. But when coming to the computer vision, here we are not manipulating any images, simply we are giving the input to the here we are giving the image as the input to the machines. Okay, then what we are doing, we are using some algorithms, we are training the machine to understand the images. Finally it will recognize even if it is the image is in the different. Okay, but we are training them to understanding the image. Okay, it will respond. Okay. As a normal machine doesn't have any intelligence, but we are making the machine to sense to the outside world. If you see, and nowadays if you see all the applications around us are, it will sensing, and automatically it will reduce the human it will reduce the human burdens. Okay, with the help of the artificial intelligence. So computer vision is a part of artificial intelligence. Here it will machines will able to see. So the how it will be able to see and how it will be able to react to the real world. That is the intention of the computer vision. What are the applications of the computer vision is, here is the object detection and even face detection. The face detection mostly you can use in a smartphone. Okay, how it will smartphone will unlock the unlock it by with the help of your face. That is the best application, as I already know. Okay, so and we'll see what is the image. Okay, and how the image is processing. First we'll see the fundamentals of image. So what is an image? You already know that proverb, a picture is 1,000 words. Okay, the picture is a worth of 1,000 words. Means by seeing a single picture, you can understand many things. Okay, so image is also as a visual data. Okay, it is a data which contains the data. It is in the form of pictorial representation. And so, what is the definition of image? Image is an array or the matrix of pixels which is arranged in the columns and rows. Generally, it's a we are capturing the 3D world into the 2D plane. Okay, it is the real scene. The real scene is captured by the 2D plane. So here you can see the images, how it is capturing with the help of some cameras. So this is the basic definition of image. What does it mean, the image? Image is a matrix. It is having the pixels. Okay, we are applying some manipulations on that pixel so that you will get the better version of that image. So you can see the image here. Here I am putting two images. These are the two images. So what will happen here? If when the mirror is reflected, when the object is reflected on the image, okay, you can see here this image is reflected on this mirror, and at the same time this image is reflected on this image. Okay, and these two images are reflected on this image 1 and 2. So how this happening? Because when the light falls on this object, automatically it will reflect it. Okay, this is the object. So what does it mean, the light? Light is a wave. It is a electromagnetic wave. When the light falls on this object, it will either it will be penetrated through it, or it will be observed by that object, or it will be reflected. So this is happening on this with this object. Okay, so automatically this image will appear on this screen. Okay, so what you observed in this is how without light the image we cannot see the objects. Okay, with the help of the light, maybe either it the sunlight or it may be the bulb, it is having some waves. Okay, the light which falls on the object, automatically that will be reflected. Okay, by the help of the reflection process, the image will be appear. See here, how does the human eyes see that images? As you already seeing the real world, and some people don't have eyes. So what is the problem with them, and how we are able to see the real world? Means how we are able to see the objects, and we can see the objects in the even daytime and the night time. But in the daytime you can see the objects very clearly when compared to the night time. Why it is happening like that? In night time, why can't we see the clear objects? Because we are able to see the objects only in the presence of light. If there is no light, we cannot see anything. So with the help of the light, so we can see the object. So here you can see how the light rays falls on this strikes with this object, and it will be reflected. If you see if you throw the ball towards the wall, automatically it will bounce back to it. Same thing happened with the light. Okay, when the light falls on the object, what it will bounce back. So that rays will be observed by the eye. So what the in the human eye, what will happen after this? So human eye will see the object. Object will reflect some rays, because a light. What is the property of light here? Light will be travel, and when will hits the object, what will happen? The matter that object will observe that light, or it may be reflected, or it may be transmitted. Okay, these are the three cases happen with the light. Okay, so when the light falls on this object, okay, it will be either reflected. So what is the property? It is reflected, or it may be transmitted, or absorption. Okay, so these are the three properties. These are the properties of light. Okay, so and it is also light having traveled with different mediums also. If it is a air medium, light travels fast when compared to the water. Okay, these are some light properties. So why I have to discuss about the light properties means here how it is how human eye is able to see this object. If there is no light, we cannot see anything. So so this is the structure of the human eye. Okay, so when the eye when this light passes on this cornea, what will happen? This is the structure of the human eye. So when the light falls on this object, this rays will passes through the cornea. This is the structure of the human eye. When the light falls on this is the light. Okay, light waves. So these waves will pass on this object apple, and when the human eye sees this object, the rays will passes through the human eye. Here we have cornea, that is the topmost layer of the eye. After the cornea, so yeah, so this is the cornea. We'll see what is the structure of human eye. So yeah, you can see here how the light will falls on this is the outer part of the human eye is the cornea. It is a transparent layer like glass. Okay, because if there is no transparent, how the light will travels towards it. So that's why cornea is a transparent layer. So when the light falls on that cornea will help to focus this light rays towards the retina. Okay, so here the cornea the light will falls on the cornea. It is a transparent layer and it will reflect. Actually light will reflect, but it in this human eye the light will refracts. Okay, we have a reflection, you know already, a reflection property as well as a refraction. Okay, this is the structure of the human eye. Here is the cornea. It is a transparent curved front surface of the eye, and it will blends the incoming light. Okay, so when light falls on the cornea, automatically cornea will transfer that light rays onto the pupil. Okay, the next layer of the eye is the pupil. A pupil is surrounded with the iris. Okay, how iris will help you the pupil based on the intensity of the light. Okay, if the intensity is low, the pupil will enlarge. If the intensity high, pupil will synchronous. Okay, so that in such way iris will help to the pupil, and the pupil will focus that light onto the retina. Okay, so in that we have lens. Okay, so when the light falls on the cornea, it will refracted, it will change to its to retina. And what will happen at the retina? Retina will transmit that electromagnetic waves to the electric wave, that light waves into the electrical waves. Okay, that will be transferred through the optical nerve. Okay, you can see here. So the retina is a light sensitive layer, and at the back of the eye we have that image will be inverted in the back of the eye. Okay, what we are seeing is everything will be inverted in the eye. So here we have photoreceptors. So the functionality of the photoreceptor in the eye is we have rods and the cones. So what is the role of rods and cones here? Rods are mostly helpful in the low light image, like in the night time. Okay, and the cones are helpful in the identifying the colors. Okay, so when light having different rays, different wavelength spectrum, we have ultraviolet and we have visible light, we have gamma rays, x-rays that cannot be seen by the human, but only human can able to see the visual light. Okay, so in that we have some different wavelengths, different colors are there in that light. Okay, that will be absorbed by the photoreceptors. So in photoreceptors also we have two different types of photoreceptors, that is only rods and cones in the retina. Okay, and mostly rods will be helpful to identify the low light image, and the cones are helpful to identify the color image. Okay, After that, after the light falls on the retina, behind the retina we have photosensitivity. Retina converts the light into the electrical signals. Okay, that electrical signals are transferred through the brain with the help of optic nerve. Okay, this is how human will able to understand the how human will able to identify the image, means how we are seeing the image. So what is the process behind this is, when the light falls on the retina, cornea after the transmitting to the cornea, so finally it will reaches to the retina. Behind the retina we have electrical signals, we have light sensitivity, after that will be converted as a electrical signals. Okay, so coming to the digital image. Okay, we have two different types of images. We have analog images and we have digital images. So analog images is a continuous function, continuous waves, and the digital image is a discrete data. So why should we learn the digital images? Why can't we research on the analog? Why can't we discuss the analog images? Because analog is the continuous data, means we cannot, it is a infinite data, we cannot apply any operations on the analog images. If you see the camera, old camera, there we have film. Okay, once the light enters onto the lens, automatically it will capture the image. Okay, and that image will be falls on the film. Okay, so with the help of some chemicals we can get the image. After that you cannot perform any operations on that image, it is a continuous data. So but we want to apply some operations on the image, I want to modify, I want to add some extra features to the image. So this is the digital image. Means how the digital image represented, this image will be represented in terms of pixels. Okay, so image having, the image is a it is a two-dimensional, having the coordinates, two-dimensional data, x and y. Image is represented in terms of pixels. It is a grid format data. Okay, we can call it as a array, matrix, grid, whatever it may be. So every pixel we can, this part is called as a pixel. Okay, so image can be represented in terms of f of x comma y. So what does it mean, x and y? Here x comma y are the coordinates of that particular location. Suppose I have the coordinates x 20, 30, 40 like that. So this is the image data. Based on these values only, that image will be, you can identify the colors of that particular image. Okay, you can see the definition. The image may be defined as a two-dimensional function f of x comma y, where x comma y is the spatial coordinates and f is the function. Okay, at any pair of coordinates x comma y is called intensity or the gray level. Okay, intensity means how it is brightness. Okay, the value of that particular pixel, it shows how the color value. Okay, what is the brightness that particular location having, that is nothing but the intense or gray level or color, you can say the color value of that particular pixel. Okay, so generally we represent the function f of x comma y. Okay, and we have analog images and we have digital images. Analog images having it is a continuous function and you cannot perform any operations on analog images. So with the help of digital images only you can perform operations, because we have some mathematical function f of x comma y. So this function will map all the values of the inputs x to the output of that particular value. So function is nothing but which will map from the all input values to the corresponding output values. Okay, so here what is the input here? Input is the that particular position will mapping to that particular pixel here. Okay, this is the position and this is the pixel. So when we are capturing the image, automatically that values, that particular image values will be stored on that particular pixel. Simply we are mapping that input image, image to that particular values. Okay. Yeah, digital image is it is a finite and the discrete quantities. Finite and it's a limited. Okay. Digital image is the limited values. Continuous image is the unlimited value. With the unlimited data, you cannot perform any operations. With the limited data only, you can perform some operations. That's why we are converting that pixel data into the limited values. So you can perform operations on that particular image. Okay. Here you can see this is the coordinates. It's the spatial coordinates of that particular that image. Here is the x0 and y0. We are representing the particular location with the help of x comma y. Spatial coordinates of this particular image. Okay. And analog images. What is the process to convert the analog image to the digital image is the sampling and the quantization. We use the sampling and quantization. With the help of sampling and quantization, that image will be converted as a digital image. If you see these two images, so how this analog image is converted as a digital image. Each pixel, this image, each value can be represented with that particular color. Okay, and each this will be converted as a pixel format, and each pixel carries its own value, its own intensity value. Okay, this is the conversion of the analog image to the digital image. Yeah, if you take this part, how many pixels are there in this? You can see here every pixel having its own color. Okay, it varies from one pixel to its neighboring pixel value. Okay, it will holds this value, that intensity of that particular pixel. It is a colored image value. Okay, each element, we can call this each pixel in the image as a pixel or picture element. Okay. Yeah, what are the different types of images we have? We have grayscale image, we have binary images, we have color image, RGB image. So what does it mean, the grayscale image? Grayscale image which having no color, only that intensity will change from 0 to 1. Okay, 0 is we have 250 colors, black and white colors. Okay, RGB. So 0 is the black color and 1 is the white color. And here, yeah, so grayscale image contains the shades of the gray value. Shades of black and white shades will only appear on the grayscale image. Okay, so that will be varies the only in between the 0 to 1, and RGB having the different values, and the binary image it is having either black or white, and color image having the colors. Okay, all colors will be appear with the help of RGB, red, green, blue. With the mixing of all color these three colors, you will get the color image. Okay, so this is the red color, green color and blue. Okay, so this is the RGB channels. Okay, we have three different images. So grayscale image is a the intensity is only varies between the 0 to 1. Means every pixel value only in between the values are varies only between the 0, either 0 or 0 0.1, 0 0.2, like that. Only the maximum value is only 1 and the minimum value is 0, and the range, the values are lies between only between the 0 to 1. Okay, this is about the grayscale image. And the binary image is only, and here we don't have any color in this, simply it will change its intensity. Okay, that intensity is only lies between the zeros, 0 to and 1. For example, our black and white image. Okay, and the binary image, it is having only 2 pixel values. 0 is the black value and the 1 is the white value. Okay, and the color images, we have 3 different colors. With the help of RGB, you will get the combination of these. You can able to see different colors. Okay, this is about the color image. Yeah, these are some examples of different images. If you see this is the binary image. The image, all pixels, either it may be 0 value or 1 value. Okay, black and white, and this is the variations of this black and white combination. This is the grayscale image, this is the binary image. Okay, binary means either pure white or pure black, but the grayscale image having the variation, the intensity varies between the 0 to 1. Okay, this is the black and white image, and this is the RGB, the combination of all these red, green, blue, you will get the multiple colors. Okay, this is the indexed image. Indexed image is nothing but it is a RGB image only, but for the storage purpose we are making them group as a colors. Okay, so how many colors in that particular image, so each color having its own value. Okay, we have these many colors are present in this image. Okay, so we are making, this is a histogram representation. So indexed image, we are giving the index to that particular color. Okay, for storage storage purpose these indexed images will be used. This is the RGB image representation. See here, we have three different, this is a three-dimensional representation. We have RGB with three channels. Okay, a red channel, green channel and the blue channel. Okay, and red channel having its own pixel values, and the green channel having its own pixel values, and the blue color as also having its own pixel values. Okay, and the combination of all these you will get the this color. A combination of all these intensity values you will get this pixel value. Okay, and this is also combination of how that waves are passing through that object, you will get this pixel value. And this is the height of the pixel, this is the width of the pixel, it is, and also we have depth of the pixel. Okay, in the RGB color images we have three parameters: height, width, depth. When it comes to the grayscale image, we have height and width, we don't have depth because there we have only one color. Here we have three colors, means the depth is three channels we have. Okay, so this is about the RGB colors. The combination of all these you will get the pixel value. With the help of these three you will get this pixel color value. Okay, and how this overlapping with the image processing. Okay, so the input is image and the output will be image, that is nothing but the image, digital image processing. Suppose if the input is image and output is the description, so you will get the computer vision, means we are making the system to sense and it will take the decision on its own. And if the input is description, means if you write any code and finally you will you will get the image, that is the graphics, computer graphics. And the input is a description and the output is description, that is the artificial intelligence, means we are giving instructions to the robot, automatically it will do some task. Okay, so this will happen with the artificial intelligence. Okay, yeah, you can refer these books for want to learn more from this. We have digital image processing, 4th edition, and also you have digital image processing and the computer vision. Okay, these are the some textbooks, you can go through it, you will get the clear idea. So what we have, I want to conclude what we discussed as of now. So what is the image processing? How the image processing is related to the computer vision, and also what is the image? Image is nothing but the set of we have image is the array, which consists of the array or the matrix, which is having the pixels, and each pixel having its own value. And if image is represented with the help of the function is f of x comma y, where x comma y are the spatial coordinates and which will represents the that intensity of that particular image. Okay, and also how human vision, how the humans are able to see the image, what is the process behind this, I have covered that topic. And finally what are the different types of images we have grayscale image and also binary image and the RGB images. These are some basic fundamentals of digital image, and we'll see the next class, we'll see the next series, what are the relationship between the pixels, or how the image, what are the operations will perform that particular image. Okay, thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.